right, for our first lesson here for chapter 0, lesson 0.1, these are some of the things that we're going to, these are some of our goals. So first we're going to use mathematical models, such as pictures, diagrams, and graphs. Those are all models. And we're going to use appropriate mathematical tools strategically. So you're going to decide what tool you're going to use and why you're going to use that. We're pretty much just going to do that by going over some examples. All right, so first of all, this is going to be a little bit of review from algebra. We're going to find the slope of that line and explain our strategy. Okay, so you remember how to find the slope of a line. Now I could choose 2 points on the line and use a formula to find that slope, change in y over change in x. Or I have this graph in front of me. Let's just use the model that we have in front of us. So remember, I have rise over run, so I have 1, 2, a rise of 2. And a run of 1, 2, 3, 4, 5, right? So I just simply use that model to find that slope. I'm missing one thing though, so hopefully some of you caught this. Is this a positive slope or a negative slope? It looks like it slopes upward to the left, so that's going to be a negative slope. So I have a slope of -2/5. So when you have this model in front of you, why go through that, using that formula to find the slope when you can just use the model that's already there? So a graph is a model. Right? So again, slope of -2/5. So in this course, while we're learning our content, we're going to use learn these different ways of thinking about and doing that. So I'm going to focus on this last part right here. Always start by thinking about, so no matter what problem we're doing, start by thinking about what the problem means, how you want to solve it, and what the solution should look like. All right, so if we think about what the solution should look like, and we get to the solution and it doesn't look like that, we know we've done something wrong. That's a really important thing, right? That's like estimation. We want to estimate that solution, and we should at least know generally what it should look like, so that we know in the end whether or not that makes sense. That should make sense. Let's look at an example. We're going to use a model. So Alindra needs to mix some lawn fertilizer with 7 liters of water. She has 2 buckets, hold 3 liters and 8 liters, respectively. So that's your elementary school days. I'm just highlighting the important information. That's my underlining. So we're going to describe, we're going to illustrate a procedure that will give exactly 7 liters of water in the 8-liter bucket. Okay? So I have a 3-liter bucket and an 8-liter bucket. So here's our 8 liters. Here's our 3 liters, more or less, right? What we need to do is fill a 7-liter bucket. We have to use this 8-liter bucket and this 3-liter bucket. I know you could just take the 7 liters, or you could take it and you could, put it under the hose. You could estimate, oh, that's about 7 liters, but we can't do that. We need exactly 7 liters. And I should go back a second. We don't actually have a 7-liter bucket. We need to put the 7 liters in here. We don't know where the 7-liter mark is, so we need to use these tools to put 7 liters into this 8-liter bucket. How are we going to do that? I think the best way to do this for me is by using pictures. Right, so think about how can we use the 8 liters and the 3 liters. Maybe you need to dump some water out, and then you can fill it again, something like that. So let's say these are filled. Well, let's take a look at the model. I said an 8-liter bucket and a 3-liter bucket, right? Well, what if I fill the 8-liter bucket, right? I'm going to fill that 8-liter bucket, and I'm going to dump as much as I can into the 3-liter bucket, okay? So now I'm left with 5 liters in here, and I'm left with that 3 liters. I'm going to get rid of that 3 liters. Okay, so get rid of the 3 liters. So again, you have 5 liters here. You have nothing left in there. All right, let me go back a second. So now what we have, I want you to think about this and maybe try it for yourself. Now remember, what I have is I have 5 liters so far, and I have nothing in here. Okay, and 0 in my 3-liter bucket. So how can I go from there to get 7 liters into this bucket? So do I have to dump more out? Do I have to refill the 3-liter bucket and pour some more in? What am I going to do from there? I'm going to have to pause for a second and see if you can figure out what you might need to fill up, what you might need to dump out. So again, pause the video and see if you can draw a model for yourself. And I saw the beginning of it in the next slide. All right, so here we go. So here's what we do from here. This is, again, just one solution. Maybe you came up with something else. So here's where we were, 5 liters and 0 liters. So what if I dump 3 more liters into here? Now I only have 2 liters left. I'm going to dump that out, right? Again, I have 2 liters in the larger bucket. What can I do from there? I'm going to take that 2 liters. I'm going to dump it into my 3-liter bucket. I'm going to fill up the 8-liter bucket. And now remember, I have 1 liter left right here. I know that, because I know there are 2 liters in there. So if I take my 8 liters and I fill up that 3-liter bucket, it means I'm filling this, putting 1 more liter in there, which means I'm left with 7 liters in my 8-liter bucket. And there's one possible solution. Save this one for class. All right, here's another example. A line passes through this point 47. It has a slope of 3/5. So find another point on that same line. What should I use here? What kind of model can I use? Should I use a graph? Can I just use an equation? Because an equation is also a model, right? Models aren't always just pictures, right? Models can also be equations. So what can I do here? I could create a coordinate grid. And I could plot my point 47, and I could use a slope of positive 3/5 and find another point on the graph, right? Or, well, that's one way to do it. If you choose to do it that way, there's nothing wrong with that. That's totally fine. You can also remember that slope is rise over run. And it looks like this slope is moving in the positive direction. So if I have an x-coordinate of 4, and my run is 5, run is going to be x-axis, right? I can just do 4 plus 5. And I'm not going to underline that. So that's going to be my x value. My x value is 9. And my rise is 3. My y value is 7. 7 plus 3. And that's going to give me 10. So again, this is x and y. So I could say a new point is 9, 10. Now that's, again, just one way to do it. If you would rather do it on a coordinate plane and find that next point, you can do that next point that way as well. That's another model. Okay? So again, this is done on a coordinate plane. But I did it a different way because I preferred to think of that other model. Let's try another one. All right, so solve the equation x plus 5 over 5 equals 2. Right? We're going to use some technology for this, so I want you to take out your graphing calculator. We're going to solve this, and we're going to verify that solution by graphing it. And that's another model. Entering this into your graphing calculator, seeing the graph on your technology, that's another model. But let's solve. So if you remember how to solve, I'm just undoing, right? So what I've done, I want to undo. Well, I've divided this side by 5, so to undo that, I'm going to multiply both sides by 5, right? So that's going to lead to, undone that, x plus 5 equals 10. Right, again, I'm going to keep undoing. It looks like I've added 5, so I'm going to subtract 5. And I end up with x equals 5. Right? So if we graph that, if we graph each side of this equation into our calculator, we enter that into our calculator. In other words, graphing each side would be, in my calculator, enter y equals x plus 5 over 5. And I would enter in y equals 2. Now, I'll show you what that looks like. So if I enter it that way, notice that my solution is for those two lines, 5, 2. So the x value was indeed 5, and that is what we got. So our solution checks out. Using this model, we can see that our solution checks out. Problem solving requires use of a variety of strategies. This is important. You may do something differently than someone else does. As long as you come to the same conclusion, your strategies are fine. As you work on the exercises, don't limit yourself. Maybe I've shown you how to do things one way. You don't have to do it that way. If you have something that you're coming up with, that's creative. That's great. Be creative in math. Nothing wrong with that. Okay. So why do we use models in math? Well, we need to come to a solution in one way, shape, or form, right? We want to use a model so that we don't make the same mistakes in real life. Think about it for a second. Why do architects build models of buildings? Well, they can manipulate that model, right? They can change things. They can make sure it works. If something isn't working, change it out. When they build the actual building, you can't just manipulate things as easily, right? They need to manipulate the model ahead of time so that when they do the actual thing, it actually works. What are some tools we could use? Okay, so again, like I said, models are representations. We use those representations because they can be physically manipulated and studied. Right? We want to be able to study and manipulate that model before we put it into action. In a building. What tools are you going to use? Well, when we think of tools, right, we have paper and pencil, so you get some trial and error. We have graphing calculators, concrete models, building something, rulers, protractors, spreadsheets, software, all of these things we have in hand to use, or to do models. What are models? One more time, models can be pictures. Models can be graphs. Models can be equations. And there are other things that are models as well, but we're going to use all these things, and you don't want to limit yourself just to one thing in whatever it is that we are studying.